So let's talk about converting fractions to decimals and decimals to fractions. Let's start with a very common example. When you see 1 over 2, you know it's 0.5, but let's look at how we go from 1/2 to 0.5 and how we go from 0.5 to 1/2. So when you have 1/2 and you want to convert it to a decimal, you use long division like this, right? So 2 goes into 1, we know it's 0 times, right? So we have 0. We're going to add a 0 here. 2 goes into 10 5 times, right? Technically, you have more like a 1.0 there. 5 times 2 is 10. Or 0.5 times 2 would be 1. And then you subtract the 2 and you get 0, right? So basically, we used long division. 2 goes in here, 0 first, and then into 1.5 times, or into 10 5 times, and then we subtract and we get 0 remainder. If you have 0.5, you can write that as 5 over 10, and then you simplify. You divide both the numerator by 5 and the denominator by 5, and you get 1 over 2. So let's repeat. When you have a fraction and you're trying to make it into a decimal, you use long division. So we use long division. When you have a decimal and you want to make it into a fraction, you write it out like this. So 0.5, so 5/10 is the same thing as 5 over 10, right? Because there's only one decimal move there. So we have 10 in the denominator, and then we simplify, and that brings us to our destination. That is how we convert from a decimal to a fraction. So let's look at terminating decimals. Let's look at this example where we have 10 over 16. So we can divide both the numerator and the denominator. We can simplify, and it'll become 5 over 8. So then we have 8 on the outside, 5 on the inside. So we know that 8 goes into 5 0 times. We're going to put a 0 behind here. 8 goes into 50 6 times. 6 times 8 is 48. So we have 2. We're going to add a 0 there. 8 goes into 20 2 times. 2 times 8 is 16. And then we have a 4. 8 goes into 40 5 times. 5 times 8 is 40. And then we're done. So converting 10 over 16 to a decimal, we get 0.625. But remember, we converted this, or we simplified that to this, and then that took us to our destination. So that is one way we can work on converting a fraction to a decimal. The next section, they give you an example where you have a mixed fraction. So 3 and 7/20 is the example that they gave you. But we have a situation with 7 and 11 over 20. So you can just leave the 7 alone, 7 point, and then focus on the 20 and the 11. Okay, so then we use long division. And using long division, we'll end up with, basically, this would be 0.55. So that will go next to, so that's 0.55. That will come over there, because that was just the 11 over 20 that we were trying to work on. And that will lead us to 7.55 as the answer to that particular problem. So what I'm going to do now is I'm going to focus on the new skills, and you can definitely do the work for the long division, but if you need more practice for that concept, let me know. So that's how we solve that next problem that we just did. So 7, 11, 20th, 11 over 20. That's how we'll get our answer. Now we have something called repeating decimals. With repeating decimals, we reduce fractions to lowest terms. If the prime factorization of the resulting denominator does not consist strictly of 2's and 5's, then the division process will never have a remainder of 0. However, repeated patterns of digits must eventually reveal themselves. So this will happen. This does happen. And they give you an example with 1 over 12. When you go on with 1 over 12, you notice it becomes 0.083333, right? And that's what happens there. So it just repeats 0.083333. So very interesting there. If we look at the problem that they gave with you try it, so that's 5 over 12. So if you're taking 5 over 12 and you want to convert it to a decimal, so let's make sure we have enough room. So we have 12 and we have 5. 12 goes into 5 0 times. So 5, and then 12 goes into 50 4 times. 4 times 12 is 48. So we have 2. The next step, we have 12 goes into 20 once. 1 times 12 is 12. We have 8. 12 goes into 80 6 times. 6 times 12 is 72. We have 8. 12 goes into 80 6 times again. 6 times 12 is 72. And notice it's going to keep repeating. Right? So what do we do at this point? We know it's going to keep repeating. So we know that 5 over 12 will be 0.4166666. Let's say I put a bar like that. So it's repeating at that point. Again, some people might use a calculator. Actually, depending on what place they want you to end. If they want you to end in the thousands place. So you can actually technically, some might write it like that if they wanted 1,000 place. Or you can say 0.4166 like that and just repeating. Or even just repeating with the 6, the bar above the 6, saying that it's repeating on and on. If you're repeating and the pattern, if you have a pattern of 0.4545, then you put the bar above the 45 if there's a situation that occurs like that. So to use a repeating bar notation, take whatever block of digits are under the repeating bar and duplicate that block of digits infinitely to the right. That's what we're doing essentially. And sometimes the repetition can be, it could be a series of maybe 5 digits or 4 digits that might be repeating over and over again. So it's very interesting stuff that happens with some of these numbers. Then they ask you to do 5 over 33 under the you try it section next to example 4. And you would notice it has a repeating pattern of 0.151515 and so on. Expressions containing both decimals and fractions. If they give you a problem like -7 over 8 minus 6.5, then I would recommend that you either convert it both to decimals or both to fractions. But it'll be ideal, again, to convert both to one consistent, whether you want to do it as fractions, -7 over 8 minus 65 over 10, which you can simplify this, but that would be doing it the fraction route, or change this to a decimal. I will tell you right now that there are math teachers, okay, these are not students alone, teachers that want to have nothing to do with decimals essentially. In certain situations, they don't want decimals, right? And depends on what the situation is, but I personally like to convert things to fractions and work with them that way. But there is a time and a place for using decimals as well. It's good to be comfortable with both. But I'm just telling you that I know of some math teachers that don't like dealing with decimals. So if you have -7 over 8 minus 65 over 10, you can divide that by 5. You can divide that by 5. So 13 over 2. So -7 over 8 minus 13 over 2. So basically now we need a common denominator. So we'll multiply this side by 4 over 4. We have -7 over 8 minus... now you have 52 over 8 minus 7 minus 52 minus 59 over 8. That cannot be simplified. You can try to, one thing you could do, you could write it as as -7 and 3 over 8. You could do that. That's good. But what I meant is in terms of like simplifying it with prime factorization, that's not going to happen. So that's just something to keep in mind. So we can look at a problem that has a fraction and a decimal. We convert either both to fractions or both to decimals. And that's what we do to work through the problem. There's famous fractions you should be aware of. 1/3 can be written as 0.333, like repeating. 2 over 3 can be written as 0.6666, repeating, right? So 0.6. Let's put a bar like that, right? That's an example. So that is one thing to keep in mind, is that 1/3 and 2/3 are very famous repeating, fractions that turn into repeating decimals that you should be familiar with. Looking at the practice problems, I would recommend just doing the first 3 odds problems. So let's say number 1, number 5, and number 7 from each section. First 3 odds, and then number 21, 23, and 25, and so on from each section. I would recommend. So 45, 47, and then it moves on 49 from that section, and so on and so forth. Let me know if you have any questions. We're just doing the first 3, and then there's 61, 63, and 65. So keep up the good work, and converting from fractions to decimals and decimals to fractions is a great skill to have. Let me know if you have any questions.